So luban is a minimalist UI language. It's intended for building web UI for scientific applications. So I'm in Caltech Center for Advanced Computing Research. As the name suggests, we do a lot of high-performance computing. For most of my work time, I do algorithm development for scientific computing, but I spend a lot of time doing web applications as well, and actually a lot of my spare time trying to build to make building web application much easier. So the first question to ask is it time to switch to web for UI for scientific applications? I will give a brief introduction to web frameworks, and I will explain what's the idea behind luban, and give a few examples of luban web applications, and thinking to the future, is there a possibility to have an integrated scientific computing environment on cloud? So there are a lot of benefits of deploying a scientific application on web. You can access your work results anywhere with internet access and browser. The application is for sure cross-platform, and you can share your work with your colleagues easily. This is showing the Google Doc where colleagues can work on the same document, and on the web it's easier to build up your community. So to sum it up, for the benefits of scientific on the web for users, users only need to have a sync client, and it can access from the application from anywhere. And it makes it easy to search, associate, organize all the relevant documents, being it real documents or scientific computing objects. It's easier to share co-authoring, and it will become an integrated environment for scientific computing. For the developers, you don't need to worry about distribution and deployments, and it's easier for you to create channels to get user feedback and improve your software. It would be easier to think about your software as services to the users. But certainly there are difficulties to do that, and here I'm just trying to list types of scientific UI. Certainly it's incomplete. So there are MATLAB-like, Origin-like, and a lot of custom-made applications, and a lot of scientific applications actually heavily rely on command line interface and scripting. And MATLAB, it has a lot of users, at least also IDL, Mathematica, Maple, a lot of similar but different packages. They provide a lot of built-in algorithms. Some provide symbolic computing, and the interface include command line and GUI. Origin kind of software, its focus is more on plotting, and less on algorithms. And this is just one example of custom scientific application called PDF GUI. The screenshot here is quite nice because it shows all the different things you want from a scientific GUI. You need plots, you need views of different kind of objects, including atomic structures, for material science, for example. And you need to have capability to walk through your object tree, etc., etc. And so this is my list of requirements for tools for building web-based scientific applications. A lot of the current web applications, Google, Facebook, etc., a lot of operations is actually database driven. It's you can see it's mostly getting records from the database and show it. But in scientific computing, we certainly need to leverage that, but also we need a lot of desktop UI-like operations. And in scientific computing, we got much more visualizations to do. And in a lot of research projects, we need live data. So, for example, in doing experiments, you want to see the data as it comes in. And a command line interface and scripting is also very useful because it's the most powerful way to drive your computations, simulations, modeling, etc. Existing solutions, there are a lot of them. Ruby on Rails probably is the oldest one. It's Ruby, though. We are in the Python community, and scientific Python certainly is leading the way in scientific applications. So let's not consider that for now. Django and a million other Python web frameworks. There are a lot of them. All of them are very similar. They do routing, they do templates, they do forms, validation, etc., etc. We have a lot of JavaScript frameworks, jQuery, Dojo, MooTools, a lot of JavaScript graphing libraries, Flood, JQ Plot, HighCharts, D3.js. Recently, the trend is trend of talk is Node.js. It's server-side JavaScript. So when we build a web application for scientific computing, often it's a clumsy combination of a few of those. So what does scientific UI developers need? We need it to make it to do things much easier than patching all kinds of code together. We need a high-level descriptive language to make it easy for scientific applications developers to write desktop UI like web apps. So that's what Luban is after. So you can just use only Python to build your UI, and you can think and develop like working on a desktop UI. It's a generic UI representation. The representation itself is very simple and naive. It's a tree structure. You can compile into code of different media. For web, it's going to be JavaScript code, HTML code. For native UI, it can be just normal Python code. And our approach is very minimalist. We seek to find the most compact set of abstractions that is powerful enough to construct good user interface. So this is a UI, an example. So the interface down there is described by a little tree structure. It has a document node at root and several children. And each element in each leaf in the tree has some attributes to define the behavior of the element. So Luban has only three kinds of objects, elements, that are things like forms, documents, paragraphs, etc., or plots. Action that are action to work on the element to change its view, etc., and events that happens when user interact with your UI. to create an interface, it's a simple Python syntax that you import luban, and there are factory methods to create root and leaves and branches. And so this is to show how to use assign actions to events. This is a little different from a normal UI application. It looks like a normal application, but what happens is you are assigning, you are describing the action, not so when you are doing on-click equals luban.a.alert, it's not doing the alert right now. It's describing that the event is attached to the description of the action. So when the click event happens, the whatever implementation of the UI will take that and interpret that action and do appropriate things. Luban is fully extensible. Its widget implementation can be replaced, enhanced very easily. You can easily add widgets, actions, events. And I'm going to show some demo. So let me go back. Let me go back here. So VF is a application called Virtual Neutron Facility. It's actually quite large project and includes a lot of different functionalities like material simulations and ray tracing, Monte Carlo neutron ray tracing simulations and material modelings. And I'm going to just to show a little bit of some corners of this application. This is just a simple atomic structure database of the virtual neutron facility, and just for you to see that the widgets and the web widgets has already matured to an extent that it can do wonderful job. And oh, sorry. This is another database that shows the phonon density of states plot. Actually, that's dispersion plot. What I choose, and you can see it's how this plot is computed, and it comes from a model, and that model comes from a paper in PR a long time ago, and so that's the one benefit of doing that in web. You have a lot of capability to associate different objects. And this is a little more complex than the previous two, where you can do simulations of neutron experiments. It looks like you are doing an experiment on a beamline, and you want to look at what's the expected. Okay, I need to save the form. What is the expected neutron beam profile? And this is already computed in the database, so you can just look at the results and zoom in. If you can look at the existing profiles, and you can also calculate new profiles. So The next application I'm going to show is called Imagine Labs. Imagine Labs is a Caltech startup based on Cosical technique. Cosical technique, at its core, is an algorithm to measure disparity between two optical images. Its main application is measure ground deformations due to earthquakes, for example. A recent new application is sand dune migrations on Mars, actually. So this is all we help GPL lab to decide if the landing site for the rover that is going to land in August, if the sand dune on that landing area is moving or not. Actually, all of them are moving. So to assess the how danger is it to land the rover over there, and so Imagine Lab is a very small company focusing on developing implementation of cutting-edge algorithms. But how to make this software available to more users? It used to be just ideal software, has an ideal software distribution, but now we are working towards provide data analysis as a service. The first step we have is a little web application that users can upload 2 images and run computations on it. But this is not enough because we need users to be assess much more advanced capabilities of this software. So a new project I'm trying to work on just recently is called nerdyland.org, and let me show a demo. So the idea here is kind of like a online MATLAB thing. You can start a new session. You can choose different servers. All of them are on the cloud. And this is a SciPy sandbox where you can type in some commands and so we could do a little plots. You basically build up 2 arrays and plot it, and then build up a pie plot. Basically, anything that you create that is an object that is plottable, it will show up in the workspace. You can switch between the plots. This is nice, but not enough. The really nice thing, when you think about MATLAB, why is it so useful for the engineers is because it can develop things very quickly and also provide a tool to build quickly the GUI for users. So here I'm showing the capability of that you are executing commands on the server side, but actually updating a client's user interface. This is just one little example. We can go back, start a new session, and try a different example. Not that one. So this is building a little more complex interface. Is creating an accordion, and in each section of the accordion, you add different plots and text. And the final result is something like that. So this is still primitive, but you can see the power. You can create easily your user interface for your user on the web. More interestingly, you can also run your script here This is a very simple script that, oh, sorry. It's just drawing a sine wave. It propagates. The nice thing about this is you can have a public view of that. Basically, when developers develop their application that knows how to update users' interface, it can send out the links to its public view to its users. And you can also stop the script. This is a little more fun, but still also primitive example. I'm plotting the Google stock price. That's it. Thank you.
So while Cyrus is setting up, we have time for one question.
So the elements we saw about the JavaScript elements.
Yeah.
So you have a number of backends. JavaScript is one backend.
I right now only have JavaScript backend, and actually I have a WS backend, but I'm not working yet actively. It works. It shows up a simple page, but it doesn't really. It's not production. Yeah.
Well, let's thank Xiao again.